Welcome to the Global Updates, bringing you the latest news from around the world. Our universe is a place of profound wonder and mystery. When we look up at the night sky, we are greeted by a vast expanse that stretches far beyond what our eyes can see. Each twinkling star, every distant galaxy, and the endless darkness in between remind us of how little we truly know about the cosmos. The universe is not just a collection of stars and planets, it is a living tapestry of phenomena that have fascinated humanity for millennia. From the swirling chaos of black holes where gravity is so intense that not even light can escape, to the bizarre and counterintuitive world of quantum mechanics, we are confronted with phenomena that challenge our very understanding of reality. Black holes warp the very fabric of space-time, creating regions where the known laws of physics break down. Meanwhile, quantum mechanics reveals a universe where particles can exist in multiple states at once, and where the act of observation itself can change the outcome of an experiment. These mysteries are not just scientific curiosities, they force us to rethink the nature of existence itself. For centuries, we have gazed at the stars and pondered the fundamental questions: what is the universe made of? How did it begin? And are we alone in this vast expanse? Ancient civilizations built monuments aligned with the stars, seeking to understand their place in the cosmos. Today, astronomers use powerful telescopes and advanced technology to peer deeper into space than ever before, searching for answers to questions that have captivated the human imagination since the dawn of time. These questions have fueled countless scientific inquiries, pushing the boundaries of human knowledge. Every discovery, from the laws of gravity to the detection of gravitational waves, has brought us one step closer to understanding the universe. Scientists from around the world collaborate, sharing ideas and data, driven by a shared curiosity and a desire to unlock the secrets of the cosmos. Their work is a testament to the power of human ingenuity and the relentless pursuit of knowledge. Yet, some mysteries remain stubbornly elusive, locked away behind complexities that our classical computers struggle to unravel. The sheer scale and intricacy of the universe present challenges that push even our most advanced technology to its limits. Simulating the behavior of subatomic particles, modeling the birth of galaxies, or decoding the signals from distant exoplanets often requires more computational power than we currently possess. As our questions grow deeper, so too does our need for new tools to help us find the answers. But what if there was a new kind of computing, one that could unlock these secrets and revolutionize our understanding of the cosmos? Imagine a technology capable of processing information in ways that defy conventional logic, opening doors to discoveries we can scarcely imagine today. This is not just a dream, it's becoming a reality, thanks to the emerging field of quantum computing. Enter quantum computing, a revolutionary technology poised to transform our world in ways we are only beginning to grasp. Unlike classical computers, which process information in binary bits, ones and zeros, quantum computers use quantum bits or qubits which can exist in multiple states simultaneously. This allows them to perform complex calculations at speeds unimaginable with traditional computers. Quantum computing holds the promise of solving problems that have stumped scientists for decades, from simulating the behavior of molecules to cracking the codes of the universe itself. This new paradigm harnesses the mind-bending principles of quantum mechanics to perform calculations that are impossible for even the most powerful classical computers. With quantum computing, we may one day unlock the secrets of dark matter and dark energy, understand the origins of the universe, and perhaps even answer the age-old question of whether we are alone. The journey to unravel the universe's greatest mysteries is just beginning, and quantum computing could be the key that opens the next chapter in our quest for knowledge. Imagine a computer that doesn't rely on the familiar binary bits, zeros and ones that have powered our digital world for decades. Instead of being limited to just two possible states, these new machines operate on a completely different set of rules, inspired by the mysterious and counterintuitive laws of quantum physics. Picture a world where the boundaries of what computers can do are pushed far beyond what we ever thought possible. Instead, quantum computers harness the strangeness of the quantum world, where particles can exist in multiple states at once. In the quantum realm, the rules are unlike anything we experience in our everyday lives. Here, particles can be in a state of superposition, meaning they can be in two or more places, or states, simultaneously. This bizarre property is at the heart of quantum computing's incredible potential. This is the essence of quantum computing, a revolutionary approach that could transform the way we solve problems, process information, and even understand the universe itself. Quantum computers are not just faster versions of classical computers, they are fundamentally different machines, built on the principles of quantum mechanics. Classical computers, the ones we use every day, store information as bits, which can be either a 0 or a 1. Every app you use, every website you visit, and every photo you take is ultimately broken down into long strings of these binary digits. This system has served us well, but it comes with limitations, especially when tackling problems that require massive amounts of computation. Quantum computers, on the other hand, use qubits. Unlike classical bits, qubits can be 0, 1, or both at the same time thanks to superposition. This means a single qubit can hold much more information than a classical bit. When you combine multiple qubits, the amount of information they can process grows exponentially, opening up entirely new possibilities for computation. This unique ability allows quantum computers to perform multiple calculations at once, giving them an exponential speed advantage for certain types of problems. For example, tasks like factoring large numbers, simulating molecules for drug discovery, or optimizing complex systems could be solved in seconds or minutes, rather than years or centuries. The potential impact on fields like cryptography, medicine, and artificial intelligence is staggering. Furthermore, quantum computers exploit phenomena like entanglement, where qubits become linked and influence each other instantaneously, even across vast distances. This means that the state of one qubit can depend on the state of another, no matter how far apart they are. Entanglement enables quantum computers to process and share information in ways that are simply impossible for classical machines. This interconnectedness opens up, honestly, unprecedented possibilities for solving complex problems that have long stumped classical computers. As scientists and engineers continue to develop and refine quantum technology, we stand on the brink of a new era in computing, one where the impossible may soon become possible, and the limits of our imagination are the only boundaries left to explore. In the year 2019, the world of technology was shaken by a truly groundbreaking announcement. Google, a company already renowned for its innovations in artificial intelligence and search technology, revealed a scientific achievement that had long been considered the holy grail of computing. The news spread rapidly across the globe, making headlines in major publications and sparking intense discussions among scientists, engineers, and tech enthusiasts alike. At the heart of this announcement was their quantum processor known as Sycamore. This remarkable piece of hardware had accomplished something that, until then, existed only in theory and speculation. It had achieved what is called quantum supremacy. Quantum supremacy refers to the moment when a quantum computer performs a calculation that is virtually impossible for even the fastest classical supercomputers. In this case, Sycamore solved a highly complex problem in a matter of minutes. A problem so intricate that it would have taken the world's most advanced classical computer thousands of years to complete. This was not just a small step forward, it was a giant leap, demonstrating the unique power of quantum mechanics harnessed for computation. The specific task Sycamore tackled was to simulate the behavior of a complex quantum system, a challenge that grows exponentially more difficult as the system becomes more intricate. By leveraging the strange and fascinating properties of quantum bits, or qubits, Sycamore was able to process information in ways that classical bits simply cannot. What's truly astonishing is the speed at which this was accomplished. Sycamore completed its calculation in just 200 seconds, less than 4 minutes. In stark contrast, the world's most powerful supercomputer at the time would have required an estimated 10,000 years to solve the same problem. This dramatic difference in performance captured the imagination of the scientific community and the public alike. This achievement was a watershed moment in the history of computing. For the first time, a quantum computer had definitively outperformed a classical computer at a specific task, proving that quantum computing is not just a theoretical possibility, but a practical reality. It opened the door to new possibilities in fields ranging from cryptography and materials science to drug discovery and artificial intelligence. However, while Sycamore's success represents a significant leap forward, it's important to remember that we are still in the early days of quantum computing. The technology is still in its infancy, and there are many challenges to overcome before quantum computers become a part of everyday life. Building and maintaining these machines requires extraordinary precision and expertise. Quantum computers are incredibly complex and delicate. They operate at temperatures close to absolute zero, and even the slightest disturbance can disrupt their calculations. Specialized equipment such as cryogenic cooling systems and ultra-clean laboratories is essential to keep the quantum bits stable and functioning correctly. Teams of highly trained engineers and scientists work tirelessly to push the boundaries of what's possible. Despite these challenges, the pace of progress in quantum computing has been nothing short of remarkable. In just a few short years, we have moved from theoretical discussions to real-world demonstrations of quantum advantage. As research accelerates and new breakthroughs emerge, it's clear that we are standing on the threshold of a quantum revolution, one that promises to reshape technology, science, and society in ways we are only beginning to imagine. The potential applications of quantum computing span across numerous fields, promising to transform industries and reshape our world. In medicine, quantum computers could revolutionize drug discovery by simulating the behavior of molecules with, unprecedented accuracy. This could lead to the development of new drugs and therapies for diseases that are currently difficult or even impossible to treat. Materials science could also be revolutionized. Quantum simulations could help design new materials with enhanced properties such as superconductivity or incredible strength. This could lead to breakthroughs in energy, transportation, and countless other industries. In finance, quantum computers could be used to develop sophisticated algorithms for risk management, portfolio optimization, and fraud detection. Their ability to analyze vast amounts of data and identify patterns could provide a significant edge in the financial markets. While the potential benefits of quantum computing are vast, this transformative technology also presents significant challenges and risks. One of the most pressing concerns is the potential impact on cybersecurity. Modern encryption algorithms, which protect our online transactions and communications, rely on the fact that classical computers would take an impractically long time to break them. However, quantum computers could potentially crack these codes with ease, rendering our current security measures obsolete. This poses a significant threat to governments, businesses, and individuals alike. Sensitive data could be compromised, financial systems could be disrupted, and national security could be jeopardized. It is crucial that we develop new quantum-resistant encryption methods to mitigate these risks. Beyond cybersecurity, quantum computing raises broader ethical and philosophical questions that we must grapple with. As with any powerful technology, the potential for misuse is a serious concern. In the wrong hands, quantum computers could be used to develop autonomous weapons systems, manipulate financial markets, or even control individuals' thoughts and actions. Furthermore, the equitable distribution of quantum computing power is crucial. If access to this transformative technology is concentrated in the hands of a few powerful entities, it could exacerbate existing inequalities and create new ones. Finally, quantum mechanics challenges our very understanding of reality. The bizarre phenomena it describes, such as superposition and entanglement, force us to confront fundamental questions about the nature of the universe and our place within it. As quantum computing transitions from theory to reality, society stands on the brink of profound transformation. Imagine classrooms where complex problems, once thought unsolvable, become interactive lessons, and students from every corner of the globe collaborate in real time to unlock new discoveries. Stock footage, animated classrooms, diverse students using futuristic tablets. The workforce will evolve as well. New fields and careers will emerge, demanding creativity, adaptability, and a spirit of lifelong learning. Quantum literacy could become as fundamental as reading and writing, empowering people everywhere to harness this technology's potential. Stock footage teams in modern offices brainstorming, workers interacting with advanced digital interfaces. In our daily lives, quantum computing promises personalized healthcare, smarter cities, and breakthroughs in sustainability. From optimizing energy grids to accelerating medical research, its ripple effects could touch every aspect of how we live, work, and connect. Stock footage cityscapes with dynamic data overlays, doctors consulting holographic scans, families in eco-friendly homes. As we face this future together, the challenge is clear: to ensure quantum computing uplifts all of humanity. With thoughtful guidance, inclusive education, and a shared vision, we can shape a world where quantum power benefits everyone, ushering in an era of hope, innovation, and boundless possibility. As we reach the end of our exploration, let's reflect on the extraordinary journey we've taken. From unraveling the universe's deepest mysteries to witnessing the birth of quantum computing, We've glimpsed a future where the impossible becomes possible. Stock footage, montage of galaxies, microchips, and scientists at work. We've seen how quantum advancements promise revolutions in medicine, materials, finance, and cybersecurity. We've navigated the ethical crossroads and imagined a world where quantum literacy empowers every individual. Stock footage, doctors with patients, engineers in labs, animated data flows, students learning together. But this is only the beginning. The quantum era isn't just for scientists and engineers, it's for all of us. Staying curious, informed, and engaged ensures we can shape this technology to serve humanity's highest ideals. Stock footage, diverse people reading articles, attending workshops, families discussing technology at home. So, what's next? Seek out knowledge, join conversations, and share what you learn. Subscribe to channels, follow the latest breakthroughs, and imagine your role in this unfolding story. The quantum revolution is coming, and together, we can ensure it's a force for good. Thank you for joining us on this journey. The future is quantum, and it begins with you. Stock footage, time-lapse of sunrise over a city, people looking towards the horizon, a glowing quantum chip,